Hi, my name is Akash M. I have currently completed my master's program in automotive engineering from VIT University, Vellore. And the topic that I have chosen for my thesis project is adoption of natural fiber composites in automobiles to reduce the effect of side impact collision under the guidance of Dr. Prabhu Kesar, who has done extensive research on the topics of natural fiber composites, suspension tuning, as well as NVH characterization of carbon composites as well as natural fiber composites. In this slide, I am going to explain about the contents of the PPT presentation. I will start from introduction based on literature survey about natural fiber composites, crashworthiness of automotive parts, the adoption of natural fiber composites, synthetic fiber composites into automobiles in order to increase the crashworthiness properties wherever it is required. Then slowly I would explain about the objectives, material selection, as well as the methodology that is being followed for this entire project. So before doing the actual simulation, I require a validation of the procedure that is being followed by the thesis project. So for that, I will do it in using a paper taken from my guide, Dr. Prabhukesar. Then slowly I would do an optimization for the geometrical parameters of the impact beam that is present inside the side door. Then I would discuss about the results that is obtained from the simulation results, and then I would try to conclude my work and I would explain something about my future work also. Regulatory bodies concerning automotive safety as well as environmental regulations are getting very strict about what kind of materials are being used for the construction of vehicles. So automotive companies are focusing more on lightweight materials such as composite materials, which allow lightweight construction as well as does not have any kind of compromise on properties of strength as well as crashworthiness. However, there is a big deficit for synthetic composite materials because they have poor recyclability and poor biodegradability. On the other hand, natural fiber composites have better biodegradability and good recyclability. Going through the literature survey, it is understood that having materials which are lightweight will increase a property known as specific energy absorption. For example, glass epoxy materials are substitute for some steel components, and the strength of the door components have increased mainly due to the weight reducing components. This is because of the increase in specific energy absorption value, which is higher for lightweight materials which absorb the same amount of energy. Also, it is understood that before doing the actual crash simulation, it is better to optimize the value for geometrical parameters of crash forces or any kind of component that we are going to adopt for the crashworthiness procedure. So this is done so that the output value, so here the output value is specific energy absorption, and it can be increased or decreased according to the priority needed to be given. After going through an array of literature based on the topics such as fiber composites, natural fiber composites, and side pole impact analysis, it is very much understood that uh, limited work were reported on pole impact test. Also, the recent NCAP regulations were not focused on. The previous researchers have observed that the hexagonal beam absorbs more energy than circular or square beams, and the parameters of the geometrical parameters are supposed to be optimized yet. No reports have been found related to natural fiber composite impact beam exclusively for side pole impact. This has less mass density than conventional material, which improves the energy absorption capability of the crash beam. Out of all the crashes that's happening around the world, 30% of all the vehicle crashes is accounted by side impact collisions. This could be explained with an example such as vehicle getting hit by a pole, a lamppost, a tree, or even a car sideways, which can cause serious injuries or even may cause death. So it is very essential to reduce the crash severity and increase the crashworthiness properties. In this project, simulation of side pole impact test is done for front door with the impact beam made of both natural fiber composite as well as steel. So the main objectives of this project is to enhance the crashworthiness of the vehicle structure. And the vehicle structure that I've chosen is the front door, side door of the car. In order to do that, I need to develop a natural fiber composite model with the optimized geometrical parameters. And the crash simulation done is for side pole impact test using NCAP rules and regulations. Another objective is to compare the energy absorption of different cross sections of the impact beam. In this project, I have chosen both hexagonal as well as circular beams in order to understand the difference that makes up for the crashworthiness properties. For the material selection of natural fiber composite, I have chosen Kenaf epoxy with 0.4 volume fraction for Kenaf fibers. This material is chosen as natural fiber composite as it delivers very good properties for mechanical characterization as well as the crashworthiness. So for the purpose of adding these properties into LS-DYNA directory for LS-DYNA pre-post, I have chosen the matte for 5455 material model. And on the right side, you can see the different types of materialistic properties. For example, Young's modulus, Poisson's ratio, shear modulus in different directions, etc. The methodology followed for the thesis project starts from geometry and dimension. So for the geometry, I have chosen a mid-size saloon car, that is Honda City, as it represents an average-sized mid-sized saloon car. And the dimension is also taken from the Honda City car. Meshing of this whole design setup is done with the help of LS-DYNA pre-post. Material is selected from literature survey. Testing conditions and simulation results will be discussed further in this PPT presentation. As I'm doing a complete software simulation project, the software that I have used for CAD modeling of the entire door components as well as assembling it together is SolidWorks 2021 Students Edition. The pole impact crash simulation on side door is simulated with the help of LS-DYNA R12 Students version. For the optimization of the geometrical parameters of the impact beam using a statistical analysis model known as design of experiment method is done with the help of a software named Design Experts version 13. In order to do the crash simulation for side impact pole test, certain sets of rules and regulations have to be followed, and I've chosen the NCAP rules. And for this, the speed of the impact pole is considered to be 29 km per hour or 8.33 meters per second going towards the direction of front door. And the pole is considered to be rigid, which means that it doesn't have any kind of deformation happening on the body. And the motion of the pole is considered to be at constant velocity, which means that there is no acceleration or deceleration during the period of contact. So this is the design setup that I have adopted and designed used with the help of SolidWorks 2021 Students Edition software. So you can see on the left side the front view, the top view, and the side view of the whole door assembly along with the pole impact. And the sheet that is present on the door is removed so that the interior components could be seen. There is a holder as well as the impact beam placed inside the door in order to absorb the energy from the crash. On the right side, you can see each of the parts. On the top, it's shown pole, which will come and crash onto the door. And there will be beam holder inside the door where the beam will be placed. Before doing the actual crash simulation, it is very essential to validate the procedure that is being followed for the crash simulation. So I have taken the material properties as well as the geometrical properties of the tube from my guide's paper, Frontal Crashworthiness Performance of Bitubular Corrugated Conical. And on this slide, you can see the result obtained from the validation procedure. And here on the left side, you can see the energy absorption graph, where the specific energy absorption value is calculated to be 1378 joules per kilogram. And on the published paper, it is shown that the absorbed energy is 1380 joules. So there is only 0.15% of error, which says that the procedure followed for the crash simulation is accurate. Before doing the crash simulation for the comparison purpose, it is very much essential to optimize the geometrical parameters of the impact beam. And here, the optimization technique used is design of experiments technique. The objective of this technique is to find the best dimensions having the best energy absorption value for the impact beam. Design Experts version 13 software was used for this task. The input factors for this study are length of the beam, outer diameter of the beam, thickness of the beam. After inputting all the values, I got the central composite design type for the response surface modeling. After inputting all the factors as well as the constraints, the final equation in terms of actual factors have been got in terms of length, diameter, and thickness of the impact beam. And on the right side, you can see the number of runs that I have run in order to find the best optimized value for the energy absorption. And the optimized values for the geometrical parameters are 805 mm length, 30 mm diameter, and thickness as 2.5 mm. With the help of response surface modeling, such as the 3D surface plot, it is very much easy to explain the kind of effect the input parameters have on the output parameters, such as the energy absorption value. So here I have constrained the value for diameter as 30 mm and 805 mm for length, and through the graph it is seen that on the left hand side, for 805 mm length as well as 30 mm diameter, the energy absorption value is 1000 joules. This is for 0.5 mm thickness of the beam. When I have increased the beam thickness from 0.5 to 2.5 mm, the energy absorption value has jumped from 1000 joules to 3670 joules. That is almost 267% increase in energy absorption. Similarly, I have chosen the parameters such as thickness value as 2.5 mm and length value as 805 mm for freezing, and I have increased the diameter from 28 mm diameter on the left side and 30 mm diameter on the right side. And the energy absorption value has jumped from 3010 joules to 3670 joules. That is 21.9% increase in value. So before doing the actual crash simulation, there are certain parameters that need to be input, such as the type of contacts applied. And in this project, I have used automatic surface-to-surface contact, spot weld contact, as well as tight shell-to-surface contact for each of the parts of the door as well as the impact pole. And for the side edges of the door assembly are fixed in every direction, whereas rest of the components are allowed to move across the z-axis, which is the axis of motion. Coming to the result section, this is the fringe plot of resultant displacement in the positive z direction for the door, and this is the bottom view. And each of the diagram represents the motion of the pole towards the door at each millisecond. For example, A is representing 0 milliseconds, and then 7.5 milliseconds, then coming to 50 milliseconds to 22 milliseconds, and then finally to 30 millisecond mark. And from this graph, it is understood that the displacement is highest for regions of door where pole comes in contact. That is, this section where the door comes in contact with the pole at the highest displacement. As you can see that the color denoted by blue is representing the highest value for resultant displacement. So this is the comparison of force values for circular beam. So for circular beam, I have introduced the material both steel as well as canap epoxy, and it is understood that the peak force value for steel is 1200 Newton, 1200 Newton, and the canap epoxy value, peak force value is 1100 Newton. So it is understood that the peak force value for steel beam is 9.1% higher than the canap epoxy beam. Similar to the previous slide, comparison of force values have been done for hexagonal beams. So in this graph, you can see that the peak force value for the steel hexagonal beam is 18,400 Newton, as well as for the canap epoxy beam is 18,200 Newton. And you can see the bottom lines are of the peak force values for the circular beams of both steel and canap epoxy materials. You can see what kind of difference makes for circular as well as hexagonal beams. And the peak force value for the steel hexagonal beam is 1.1% greater than that of canap epoxy hexagonal beam. Another property which has been focused is the energy absorption value, and in this slide we can see for the comparison of circular beams. So the energy absorption value for total energy absorption value for the steel circular beam is 350 kilojoules, and for the canap epoxy tube it is 507 kilojoules. So the energy absorption value for canap epoxy beam is 61% higher than that of the steel beam. Similarly, the energy absorption comparison has been done for hexagonal beams, and it is understood that the total energy absorption value for the steel beam is 6,200 kilojoules, whereas for canap epoxy hexagonal beam it is 6,730 kilojoules. So the energy absorption value for canap epoxy beam is 8.55% higher than that of steel beam. Also, it is understood that the circular beams have much less uh, crashworthiness properties than that of hexagonal beams. So it can be concluded that the design of experiment technique has given the optimized values for the input parameters like length, diameter, and thickness of the impact beam for the best output parameter, that is the energy absorption value. And the resultant peak force value is greater for steel component compared to canap epoxy component for both circular as well as hexagonal beams. So this shows that the canap epoxy impact beam has less deceleration value, which means that it is better for impact loads. Energy absorption value is greater for canap epoxy impact beam for both circular as well as hexagonal beams than the one with the steel. So this proves that natural fiber composite is better choice for absorbing and impact loads in vehicular components. Lastly, the hexagonal beams absorb more energy and also absorbs much more peak force values with a much smaller displacement, which proves that the hexagonal beams are much better choice than the circular. For the future work, The work done can be implemented with additional work such as instead of focusing on just a side door, a whole vehicular design can be adopted or the crash analysis. This will give much better results concerning the distribution of forces around the structure. An actual crash testing could be done using natural fiber composites as substitute to steel in many other components other than impact beam to understand and verify the simulation results. Many other natural fiber composites, many other composites as well as synthetic composites could be introduced for the crash analysis to understand the relative performance and to find out which kind of material suits best for the task. So these are some of the references that I followed for my thesis work. So that's all from my side. Hope you have understood what I have been doing in my thesis project and wish you all the best if you are trying to pursue in this kind of experimental work as well as the simulation work. Thank you.